Hey Derek, you ready? Okay. All right. Okay, ladies and gentlemen, last day as a quick review. Okay, this is what we actually did. I started out by asking you to sketch what we call the regular quadratic, okay, which is the y equals x squared term. And then I called that the regular bag of chips, remember? And then we did things to it. We made it more spicy by adding a number at the end. So you have like x plus 3 or x squared plus 3 or x squared minus 4. And what happened there was the graph shifted up or down. So we talked about that. And then I did something else to it where I changed it and made it x minus 2 or x plus 5 before squaring it. And that's the one where you shifted it horizontally. Now, I told you to be careful because it's kind of confusing as to what happens, okay? If you are looking at the entire function x minus p, the whole thing, if you see a minus, then it goes to the right, okay? And if you're looking at the whole thing and where you see a plus sign, then it goes to the left, okay? The other way of thinking about it is if you just look at the p-value, and I showed you up here that if it was x minus 2, the p-value is actually 2. And if it's x plus 5 here, then of course this is the same thing as x minus negative 5, so therefore the p-value is negative 5. If you like looking at the p-value, then once again the p-value, if it's positive, goes to the right. If it's negative, goes to the left. Let me warn you right now, okay? This is the confusing part. So either you remember this part here where it's bigger than 0 or less than 0 for p, and notice that if p is positive, it's right. If p is negative, it's left. Or you make your decision and say, I'm going to look at the entire function. If I see a minus sign inside the bracket, that means it goes right. If I see a plus sign inside the bracket, that means it goes left. Make the choice and stick to one, or you're going to get confused. Okay? Then we looked at looking at something called the vertex, and I told you the vertex is just a shift left and right, up and down. I introduced these two values, p and q, which is the coordinates of the vertex. And then we looked at also this a value. And notice what happened with the a value. If a is positive, the graph always opens upward. If it's negative, it opens downward. And if you look at the actual number, if the number itself is bigger than 1, we call it vertical expansion. Remember taking Aileen's hair tie and stretching it? Vertically expanded. Whereas if it was less than 1, we made it flatter. It was compressed. We call it a vertical compression. Okay? And that leads us to today. So let's turn to page 4 now. And I'm going to switch it around where I'm going to ask you now to find equations for me. Okay. Remember in general, and please write this down on the top, okay, the general vertex form is, as a quick reminder, I think it's y equals to a with a bracket, x minus p, all squared, plus q. Okay? And in question number 4, it says, write the equation of a parabola that, first of all, opens down. So when you hear opens down, what do you know about the a value? A is negative. Thanks. Okay, so a is negative. Good. Okay. And for part 1, it says, write the equation of a parabola that opens down and also is congruent to y equals to 1/3 x squared. Congruent just means the following. Okay? Congruent just means the same a value. So in this example, you see how it's y equals to 1/3 x squared. What's the a value of this one? Well, it's 1/3. So therefore, I'm saying a equals to 1/3. But because it opens down, I need to put something else in front. That's a negative sign. Good. Yeah, it does. But I guess it's the same a value in terms of the actual number, but not the sign. So therefore now, I'm going to say to you, your equation just becomes y equals to negative 1/3 x squared, and that's it. You're done. Okay, so let's do part B.
Did you hear what I said? Did you really?
Part B. Notice it says congruent once again. So what's the a value from this equation? A seems to be equal to 2. But because it opens down, I'm going to put a negative in front. Okay, notice here it also says the vertex is 1, 4. So remember how the vertex, you can find the values of p and q? Can someone suggest to me what p is and what q is? 1 for p, that's right, the x value, q is 4. And so now once you have all these pieces of information, just go ahead and plug it into the formula. Y equals to -2, bracket x minus p, which is the 1. Don't forget the square, okay? We're doing quadratics now. You have to have a square. And then plus 4. Done. There's your equation. Okay? So in your homework, you're going to be looking at questions where they'll give you information. You have to come up with the equation. Now, the next part. Let's just summarize all that we've done so far. The vertex form of the quadratic function is given by this formula. And you need to memorize this, okay? It's in a box. Memorize. X minus p all squared plus q. Okay? So that's the general form of a quadratic function. Just like how the equation of a line was y equals mx plus b, the equation of a quadratic function is this. Now, what is a again? Well, a is what we call the stretch factor. It determines if it's stretched or flattened out. And what else does the a value to determine? Oh, s. Hey. That's why I don't teach English. Is that better? Okay. And what else does the A tell you then? Determines the direction of the opening. If A is positive, which way does it open? Yeah, so I'll draw pictures here for you. Okay, this is if A is positive, and then if A is negative, it opens downward. Good. We have a special name for P comma Q. What would that be called? The vertex. Good. And this last one is kind of interesting. And the axis of symmetry is given by the equation what? Well, remember the axis of symmetry was that line that cuts the parabola into two equal parts. Where does that line go through? The vertex. Good. So it's a it's a vertical line. So we give the equation x equals 2. And what's the horizontal coordinate of the vertex? It's p, so therefore it's x equals to p. Okay? Now, here's what I'd like you to do. I've given you an equation. Okay? I want you to find the following things. I want you to find the vertex, direction of opening, domain, range, the max or min value. You have to choose. Okay? Don't know which one it is. The axis of symmetry, y-intercept, x-intercept, and then after you do all that, do a sketch. Okay? I'm going to give you a few minutes to think about this. Okay, work on it together if you need to, and then I'll come back and chat. All right? So go ahead and work on number 5. Okay, what's the vertex here? Vertex, all you need to do is look at the equation, your p and the q value. So 3, 8. Okay? Now, how do we figure out the direction of opening? Well, we're looking at the sign in front of the a value. Since it's negative, it opens down. Now, by the way, you should have enough information to already do a quick sketch. Okay, you don't need to do this right now, but 3, 8. This is the vertex. Okay, and then if you know it opens downward, it should be looking like this somehow. Okay, you already have a good idea of what it looks like. How about the domains? This is from last year. Remember we talked about domain and range? Domain means all the possible x values. So what are all the possible x values of this graph? It's everything, all real numbers. So either you write down x is all real numbers, or if you like the actual notation, that's this, x, and it's a sideways e with an r with a double bar. That represents x belongs to the set of all real numbers. To make it more official, they put these curvy brackets here like this, x, and then say, well, there's your answer. So it's up to you. For me, if you give me this in blue, just like that, that's perfectly fine. Okay? And then if you think about the range, we're talking about the y values. So what are the possible y values here? Well, it looks like the highest y value is 8, and everything else is less than that. So how do we describe it? Y should be less than or equal to, right? It can equal 8. And once again, if you want to make it formal, you put that squiggly bracket with the y in front, but you don't need to.
I have a question.
Yes,
For
Rebecca.
direction of opening, which negative were you looking at? The one
Direction of opening, I'm looking at this negative here in front of the bracket. It's the a value. Max, min. Where is the max or the min? First of all, which one do we have? A max or a min? Which one? Max. So can I ask you to cross out the word min then? We know it's a max because the direction of opening is down. And what is the actual value? Now, when I say value, we're always talking about the y value here. So what is the highest value of y for this graph?
8.
8. Very good. So once again, your vertex tells you so much stuff. Axis of symmetry, also from the vertex. Where is it? It's right here, right?
3.
So it looks like it's 3. And don't just write 3 because it's an equation. I want you to say x equals to 3.
So axis is just asking for 8. I mean for x.
P, yeah, x. The axis of symmetry is always x equals to something, yes. How do you find the y-intercept? Let x equal to 0. So if you were to let x equal to 0 and plug it in, here's what you get. Okay. And then let's go ahead, make sure you use the rules of bedmass. What do we do first? Brackets, so that's -3 all squared. And by the way, you don't need to write out all these steps if you don't want to, but I'm doing it anyways. Then, of course, do the exponents first. -3 squared is 9, so -2 times 9. And what's -2 times 9? That's -18 plus 8 is -10. So your y-intercept is 0, -10. Okay? Which means maybe I should fix up my graph now, because I know it actually goes to this point down here. Right, your y-intercept, so I guess the graph looks something like this. Okay. Still not too sure about the rest, but that's okay. And then the hardest one, the x-intercept. How do we find the x-intercept? Y is 0. Good. Let y equal 0, and let's solve. So 0 equals to -2, bracket x minus 3 squared, plus 8. And then we get to something that's quite interesting. How do you want to solve this?
Multiply it back in a factor.
Okay, I have a suggestion here. Expand, factor, solve. That's choice number 1. Anybody else have another choice?
Guess and check.
Guess and check. Even worse.
Supposed to be hard.
Is it supposed to be hard? No.
Aren't you just solving for x?
That's right. You're just solving for x. So how would you solve for x here?
Okay. So
Someone said quadratic formula. You could, but that's still a lot of work. Remember, when you solve for x, you want to isolate x. So let's just keep x by itself. What should I get rid of then if I want to keep x by itself?
-8.
Okay, let's get rid of the 8 first of all. Let's do this. Yes, let's get rid of the 8. So what's 0 minus 8? Well, that's -8. Remember, our goal when we're solving for x is to isolate x. What's next then?
Divide by -2.
Sure, Rebecca says let's get rid of that -2.
So we just go 4.
So
Positive 4.
-8 divided by -2 is +4. I like that. And now what? I want x by itself.
Square root.
Square root, thank you. What's the square root of 4?
2.
2. Oh, thank you. 2 or -2.
What? Oh,
Plus minus. When you take the square root on both sides, plus minus. Okay? Which means the following. Guess what? That means you have actually now 2 answers. You either have 2 equals to x minus 3, or you have -2 equals to x minus 3. So notice that you have 2 answers for x. And that should make sense in a second when we graph this out. So we'll add 3 to both sides, so you get x equals to 5 and also x equals to 1, which means your x-intercepts are 5, 0 and 1, 0. Okay? So I'd like you to go back to your graph now and fix it up a little bit, because notice that we have here 2 x-intercepts, which makes sense because the parabola opens downward, right? It crosses the x-axis at 2 different points. Well, let's fix up our graph now. I'll tell you that one of the coordinates is 1, 0, which is nice. And where's the other one? 5, 0. And now, if you fix up your graph, this is the nicer picture. Okay?
you already made it so ugly. Now they have to fix
Any questions for me about this example here? Okay. Yes, Derek.
When you're given, what would the formula look like if the vertex was, if one of the vertexes were negative, so either x or y or both?
Okay, ladies and gentlemen, so here's Derek's question. What would the formula look like if one of the vertexes was negative? Okay, let me just quickly show you this, okay? Don't need to write this down, just watch. Okay, Derek, both these are positive right now, right? So the equation would be x minus 1 plus 5. Agreed? If I change one of them, let's say this is now negative 2 comma 6, then your new equation will be a bracket x, and it'd be x minus negative 2 plus 6. What's minus negative? That just becomes positive, so that's why it's positive. This x coordinate, the sign changes. The y stays the same. If I do one more, let's say this is 5 and negative 8, then that, once again, this becomes ax minus negative 5 minus 8. And of course, that just becomes x plus 5, all squared, minus 8. Does that help you? Okay. All right, let's turn the page, please. Let's go back to your notes. Page 5. So here, I'm asking you to do the opposite. I give you the picture. It's your job to find the equation. Okay? And once again, what's the general form for the equation? Let's write this out. Y equals to a bracket x minus p all squared plus q. You will need to memorize that. You'll be sick and tired of hearing that from me after today, hopefully. Okay? All right, let's take a look. Here's a picture of a graph. Do you know anything interesting about this graph? Can you tell me any points on this graph? Vertex, I heard. What's the vertex? 1, 2. Good. Now, because you know the vertex, then I think you know 2 of the 3 letters, right? What's P? What's Q? P is 1, yeah? Thanks, Alex. Q is 2. So I guess we can already plug in those values into the equation. So I'll say y equals to a bracket x minus 1 all squared plus 2. Hey, that's pretty good. Because with an equation, all I need now is to figure out a.
You kind of know the y-axis, the y-intercept?
You kind of know the y-intercept. Okay, what is the y-intercept here?
0.
Oh, 1. Okay, so Rebecca here says, well, we know the y-intercept. That's cool. But how is that going to help us solve for a? Yeah, plug it in. So if you want to solve for a, all you need to do is just plug in a point that is actually on the curve. And since you just told me that the point on the curve is 0, 1, let's plug that in. Okay, so in this case, I'm going to plug in the y-intercept. So what's my y value here?
1.
1, good. A is the thing we're looking for, so let's keep it as a. Bracket 0 minus 1, all squared plus 2. Good. Go ahead and solve for a. Follow the rules of bedmass. Do the brackets first. 0 minus 1 is negative 1. Negative 1 squared is 1. A times 1 is just a. So we have a plus 2 equals to 1. Well, let's solve for a. We'll subtract 2 off of both sides. A equals to negative 1. And therefore, your equation, once again, and you have to write this out, is y equals to negative 1 bracket x minus p, which was the number 1, all squared plus 2. And there you go. That's the equation that corresponds to that picture.
That's it.
That's it. Okay. Now,
Something's not right.
you know,
Yes, I think we're challenging this.
you know, you looked at the y-coordinate or the y-intercept, and that's what you found as a coordinate. Great, but you didn't have to use that one. What else could you have used instead of 0, 1 to solve for a?
2, 1.
You can use the x-intercept if you can find it, but the x-intercept's hard to find, so I wouldn't even do that.
2, 1.
I wouldn't use, you could use 2, 1 over here, you bet. You could have also used maybe this point down here, 3, negative 2. So any particular point on this graph, okay, you can use. But try to find nice points, okay? Don't use like 3.2578, you know. That's just bad. Okay, you try part B, please, on your own. Go for it. Part B just has no picture, but it gives you all the information you need. So try it, please, on your own. Part B. Fun. Okay?
Every time we say something fun, it's really not fun.
Every time I say something's fun, it's not planned? Not fun? Okay, well then it's not fun. Okay, there's your vertex. There's your P and Q. Plug in the y-intercept of 5. So plug in 5 for y, plug in 0 for x, and then let's solve. Once again, negative 1 squared is 1, so that's a. We'll solve for a. Is a 2? Okay. Ladies and gentlemen, give yourself a pat on the back if that's what you got as your answer.
Yay, I got that.
Wait, why
You
is it
too,
minus?
listening online.
Wait, why is it minus?
Why is it a minus?
Yeah.
Because the p value is 1, and the general format is x minus p.
Whoopsies. Yeah.
Right.
Never mind.
Okay. Shh. Okay, let's quiet, please. This one's tough. All right. Okay, here's example number 7. This one's tough. Shh. Sahil, please. Okay. So here's a question that says, find the equation of the parabola, once again. Okay, but notice this time you don't have the y-intercepts or you don't have the vertex. What you do have is the axis of symmetry equals to 2, and that it passes through these points. So once again, let's first of all write down the general form. Help me out, somebody. Y equals to a bracket x minus p all squared plus q. Okay. Now, from the axis of symmetry, you should be able to tell me one of those values, a, p, or q. Which one? P. Right? X equals to p is the axis of symmetry, so therefore p equals to what number? 2. Okay, so you know that the axis of symmetry is here, so you know that the vertex lies along this line somewhere. Okay, that's good. So I'm going to write this in. Y equals to a bracket x minus 2 all squared plus q. That's a good first step. Now what? It passes through, yes. It passes through the point 3, 4. So if it passes through the point, what can I do with that point? Plug it in. Okay, so let me ask you in step 1 here to actually plug in the point 3, 4. And let's see what happens when we plug it in. You'll have 4 equals to a bracket 3 minus 2 all squared plus q. Now, it doesn't help us too much, but it does simplify things a little bit. What's the simplification of the stuff in the bracket? 3 minus 2 is 1. 1 squared is 1. So all you have here is 4 equals to a plus q. Still not so great, but not too bad. Oh, right. Use the other point someone suggested. Okay, so let's also plug in the other point into the equation. So let's plug in negative 2, negative 11 back into that equation in red, and let's see what else we get. So negative 11 equals to a bracket negative 2 take away 2 all squared plus q. And we're going to now continue this. So negative 2 minus 2 is what? Negative 4. Negative 4 all squared is 16, you bet. So 16a plus q equals to negative 11. So what? Oh, good times from grade 10 coming back to think about this. Yeah? Grade 10, 2 equations, 2 variables. What do we do? Yes, you can either do substitution or you can do elimination where you subtract the 2 equations. What do you want to do? I don't care. You want to do substitution? Do substitution. You want to do elimination? Do elimination. I'll do elimination today, just for fun. Okay, so now say solve for A and Q, Okay, and this is your choice, right? By using elimination or substitution. And if you forgot what that stuff was, see Chapter 7 notes of Math 10, which I know you all kept. Did you not?
Yep.
Oh, for math I did. Oh, thank God.
Yeah, about that. I don't want to hear that. All that hard work that you put in and I put in. Recycled. Huh? You keep it with you? Oh, in your head. Okay, good. I thought you kept it like with you, like you wrapped it around your body. That's what I was going to say too. But in any case, let's, by the way, in this case by elimination, which variable do you want me to eliminate first of all, A or Q? Q seems to be the easier one. Should I add or subtract? Subtract, yes. So 4 take away negative 11 is, I think, positive 15. A take away 16A is just negative 15A. So A, oh, that's very nice. A equals to negative 1.
Wait.
What's Q then? Yeah, so now you gotta plug it back in to solve for Q. So now solve for Q. And I'll use the green equation because it looks easier. 4 equals to negative 1 plus Q. And I think therefore Q equals to 5. So then yes, the equation, and that's what you're looking for. Y equals to negative 1 x minus 2 all squared plus 5. Ta-da. And now, can you please use this equation to sketch your graph?
I have a question.
Question, yes.
Is it always negative?
Is it always negative? X minus P?
Yeah.
Yeah. That's the general thing. Always negative.
So it's
Depending on how you place your picture, this actually can become really easy. Okay, so you have to be kind of strategic right now. Let me read the question to you. Let's see if we can get a general idea of the picture, and then I'll give you a big hint as to where I want you to put the axes. Okay? Here's a question. A bridge over a river is supported by a parabolic arch. So this is the idea, okay? You've got this parabolic arch, and you can draw this in your notes, please. And you've got the bridge up top, right? Here's the bridge up top. And notice it says the parabolic arch is 40 meters wide. So the distance from here to here is 40. Okay? Now, once again, it's 40 meters wide at water level. So think about here being water level, okay? Oops, water shouldn't be red. Water is black, right? Or not black, blue. Blue. Don't drink water if it's black, okay? All right. Now, what else does the question say here?
height is 16.
Height is 16. Good. Now, here's the deal. Shh, listen up. This is important. It says, write a quadratic equation to represent this arch. I want you to come up with an equation that describes this parabola. Now, there are multiple answers. There are multiple correct answers. But there's one answer that's easier to find than other ones. Okay, now, put your pencils down. I don't want you to copy what I'm going to do. Your job is to try to put this on a grid, right, on a coordinate axis. So where could you put it? Don't copy this down. Watch. I guess you could put it here, right? Like here. Right? I guess you could put it, oops. I guess you can put it here. Right? Still parabola. I guess you can put it here. The parabola's up there. Right? I guess you can put it here. The parabola's down there. I guess you can put it over here. So the parabola's over there. So the question is, where should I put it to make this easy for me?
0, 0.
Where? Vertex at 0. Okay, so here's your choice. Okay? Don't write this down yet, okay? You can either choose to put it here, which is what someone said, make the vertex at 0, 0 the origin. Okay? Or anyone else have another suggestion? So this was one option, yes. but I think there's another one that might be a little bit better for this scenario. I would say, I think putting the y-axis here is good, but instead of having the x-axis at the bridge level, I'm going to do it at water level. Yeah. Okay? So it's up to you. Okay? But I'm going to put it at water level because water level, the height is 0. Okay. So can you now use your pencil and please put in an axis at the y-axis, of course, cutting down the middle, and the x-axis at water level. Okay, so please put that in. Now, how is this going to help us out? Well, can you now determine the coordinate of the vertex in this particular picture? How would I describe this point up here? What are the coordinates of x and y? 0 for x, good, because it's on the y-axis. And because it went up 16, 0, 16. Got it. Cool. By the way, we need another point, don't we, to figure out the a value. Can you describe another point for me on this here?
20.
20, 0. 20, 0. This point down here is 20, 0. Good. Is there another one we could have used, by the way, besides that one?
Negative 20.
Oh, yes. Or negative 20, 0. Your choice. Okay? So, let's figure this out now. Okay? Once again, let's write out the equation. Y equals to a bracket x minus p all squared plus q. Okay? What's the p and q value, please? P is 0, right? Okay, so I'm going to put in 0. And then q is 16. By the way, x minus 0, don't say 0. It's actually x, so a times x all squared plus 16. And ladies and gentlemen, how should I solve for a? Plug in a point. I'll plug in which point? 20 and 0? Sure. Okay, now you're going to get big numbers here, but that's okay. 20 squared, I think, is 400. 400a plus 16 equals to 0. Therefore, if I do some algebra and try to solve for a, negative 16 over 400. Can someone simplify that for me? What's that? Negative 1 over 25? Okay. So therefore now, your equation is y equals to negative 1 over 25. That's your a value. Your x, and there's no p, so x squared plus q, which is 16. There you go. So now you've actually come up with an equation for this parabola. Yes, Derek. Question.
We're not allowed to use the vertex for x and y, right? We can only
No, you have to use a different value for x and y, because if you put in the vertex, you'll get 0 equals 0, right? On both sides, and you'll be like, yeah, they equal, but you can't solve for a. Right? So don't plug in the vertex. Yes. To solve for a, don't plug in the vertex. Thank you. Now, why do we want to even find out these equations? Well, you can use the equations to actually answer some other questions, like part B, where it says, how high is the arch at a point 10 meters away? Now, when I say at a point 10 meters away, that means on my diagram, I am now walking from the center, I guess 10 meters either to the right or to the left. Does it matter which way I go? No. Because it's symmetric, right? So who cares? So in this case, what I'm saying is how high is the arch? So when I say how high, I'm trying to find the y value. And when I say at a point 10 meters away, that means x equals to 10. So go ahead now and do this, please. Part B says find the height when x equals to 10. So please use our new equation that you just created, negative 1 over 25 x squared plus 16.
Well, how do you know x is 10?
How do I know x is 10? Because it says at a point 10 meters from the center.
Well, why is it x?
Well, I'm walking 10 meters away from the center.
But
How
wouldn't it be
high?
zero?
How high would be the height?
Would it not just be 0 if you go that way?
Yeah, so 0 going to the horizontal is 10 meters. So
wouldn't
10.
the height be 10, like be 0? Wait, like can you draw the point where?
Okay, here's where I'm talking about, right here. Here's 10. So I'm asking you, what's the height?
Oh.
What's this distance here? Okay? So just plug in 10, please. What's 10 squared? That's 100, right? 100 divided by 25, that's 4, right? So guess what? 4 or negative 4 plus 16 is equal to 12, so I guess it's 12 meters away. Okay.
10 meters high.
10 meters, yeah, not away, sorry, 10 meters high.
12.
Good. 12 meters high. Yeah. Okay. Let me now try the last one with you, and I actually won't do part B, I only do part A, because I think I want you to try part B on your own. Okay? By the way, you all live in Vancouver, right? Do you know what the Lionsgate Bridge is? Yeah? The one that connects Stanley Park to like North Van?
Here?
It looks like this?
That thing, what do you mean
That thing, that bridge you drive over when you go to Park Royal to shop, for those of you who like to shop?
Yeah, Park
Or you go to the ferry terminal in West Van? Or you
You
go up
Park Royal,
to
there's such a nice view of the...
Final Destination? It was filmed there?
Where?
Final Destination was filmed on
Where?
Lionsgate Bridge.
Really? Which one? So they broke it, really?
Okay. Let's go back to the question here, please. All right. So, here's what we're asked to do. Shh, I'll wait for you guys to be quiet, and I'll do this, okay? All right, so it says the deck of the Lionsgate Bridge in Vancouver is suspended by two main cables, okay, attached to the tops of two supporting towers. This is actually real data, okay? This is real data. So here's the two towers, right? Tower, and then the cable is this thing here, like that, right? It says, between the towers, the main cable takes the shape of a parabola as they support the weight of the deck. And it says the towers are 111 meters tall relative to the water's surface, okay, and are 472 meters apart. And then it also says the lowest point of the cables is 67 meters above the water surface. So with all this information, I'm asking you to model the shape of the parabola using a quadratic function. How are we ever going to do this? We will right now. Let me show you how. So you see how it says relative to the water surface? So let's make our water surface down here. I'm going to draw this out again. So here's water.
Is this some regular stuff?
Okay, and I'm going to ask you to draw those two towers. And it says the towers are 111 meters tall. So I guess here's your first tower, and here's another tower. Okay, and they are 111 meters tall. So the distance here is 111. Okay, and then what happens is they are 472 meters apart. So the distance between these two towers here is 472. And what else does it say here? Excuse me, the lowest point is what? Excuse me. The lowest point of the cables is 67 meters above the water surface. So if I were to draw the cable like this, coming down, the lowest point here is 67 meters above the water's surface. Okay. So once again, you've got lots of choices as to where you can put the axes. But as a suggestion, where do you think I should put the x-axis? Okay, you can either put it on top here, which I would not do because I don't like it being down there, but I would probably use water level. So I would say at the water level, we'll use the x-axis. Okay, that just means that all the heights will be positive. So I don't know, I like having heights being positive, that's all. Where would you put the y-axis then?
On the 67.
Right, in the middle, so you don't have to have a p-value. So I would put it right in the middle here. Very good. So there's your y. Good. Okay, now, can someone suggest to me what your vertex would be then?
067.
Good, 067. This point here is your vertex. Okay, vertex. And that would be 0.67. Good. And then my question to you afterwards would be, well, is there another point on this parabola that I can actually use to figure out the A value? 236? Where'd that come from? Where?
No idea.
Where'd the number 236 come from?
472 divided by 2.
Nice. Can you see how this is 472 degrees from one tower to the next? Not degrees, meters. And once again, the parabola is always symmetric about the axis of symmetry. So you can cut it in half. Half of 472 is 236, correct. So I'm thinking this point right here at the tip of the tower, we can use the coordinate 236. And what's the y coordinate there? 111. Okay, ladies and gentlemen, I gave you the vertex. I gave you the coordinate. I think you can find the equation now. Try it, please, on your own. This too, since time is almost done, so I'll say y equals to a bracket x minus p all squared plus q. And since you told me the vertex is 0, comma 67, I'll say x minus 0 all squared plus 67. And then I think you want me to plug in the value of 111 for y, 236 for x, plus 67, and solve for a. I'll subtract 67 off of both sides. So what's that? 44, is it?
Yeah.
And then what's 236 squared?
5 something.
55676. So if you want to leave your answer as a fraction, which actually probably is more accurate, I'd just say leave it as 55676. Don't even do the decimal for me. Okay? I would, in these questions, keep it as a fraction. And so therefore, my answer would be y equals to 44 over 55,676 times x squared plus 67. And this is the equation you can use to model the swing or the parabolic cables of the Lionsgate Bridge. Okay? Let me just give you a hint for the last one, part B, and I'll send you on your way. Determine the height of the surface of the water of a point on the cables that is 90 meters horizontally from one of the towers. Okay, this means this. I'm at one end of the tower, and I'm going 90 meters to the left. So this distance in purple is 90 meters. So the question I have for you is, well, what is the height at this point? So what is the actual x-coordinate at this point? What is it? Yeah, 236 minus 90. Good. So the x-coordinate was actually at 146. So this one says, find the y value when x is equal to 146. You plug it in, you solve, I'll give you the answer next day. All right?